model exponential growth. So exponential growth, and we're going to focus on the continuous kind here, has the formula a sub t equals a sub 0 e to the rt. You might also see this as a sub t equals a sub 0 e to the kt, where k and r mean the same thing. That is the growth rate. So in this case, r is positive because we are dealing with growth. T is our time, and a sub 0 is just the initial amount. So they use this like a sub 0 to say the amount at time 0, which is when we start, right? Over here is the amount after the given amount of time, whatever we're trying to find. So let's do some examples. $5,000 is invested in an account that earns 2.6% annually, compounded continuously. How much will be in the account in 18 years? All right, so we think through this. A sub t equals initial amount times e to the rt. Well, what do we know? Well, we're talking about 18 years. So the amount after 18 years, that's what that means. Initial amount, 5,000. E raised to the 0.026 times 18 years. Right? Just what do you know? I always start by writing the formula down and then just substituting in as I go. Order of operation says do the exponents first. So 5,000 e raised to the 0.468 power. Now I can do e raised to the 0.468 power, which gives me a very ugly decimal of 1.5967. It goes on and on and on. Don't round in your calculator. Just keep that number and then hit times 5,000. And that will give you 7,983.9870. Goes on and on and on. But we went around to the nearest cent. So that's 2 decimal places. I look at the 7. 7 tells me to round up. So the amount after 18 years will be $7,983.99. Let's do one more. Scientists are researching a new antibiotic. A petri dish with 20 bacteria grow at a continuous rate of 8.8% per hour. How many bacteria will there be in 48 hours when they test the antibiotic? Round to the nearest whole number. Okay, so again, I start with my just general formula. A sub t equals a sub 0 e to the rt. Now, what do I know? I know 48 hours is my time period. So the amount after 48 hours will be the initial amount, 20, times e, which is our constant, raised to the rate, which is 8.8 as a decimal, so 0.088, times the time, which is 48 hours. Order of operation says exponents next. So 0.088 times 48 gives me 4.224. Now I can take e raised, so make sure you put that in parentheses, right? 4.224, and I get a decimal of 68.306. Goes on and on and on. Don't round, just hit times 20, and the amount after 48 hours is 1,366.12, whatever, but rounded to the nearest whole number, 1,366 bacteria after 48 hours.